What up, athletes? Let's do this today. All right, here's your warm-up. Go ahead and work on it. Pause me because I'm going to do it in just a second. Awesome. All right, so here we go. Corresponding angles, right? Corresponding angles are like angle 1 and angle 5, angle 4 and other ones could be angle 2 and angle 6, or angle 3 and angle 7, okay? So in this case, what am I going to have? Corresponding angle is angle 1, angle 5, angle 2, and angle 6, right? Those are corresponding angles, and they are congruent. Alternate interior angles, interior means inside, so we're talking about this inside area, right, inside the two lines. And then alternate means they're on opposite. Oh, you can hear my lunch beeping right there. So sorry. Alternate means on opposite sides. So what are we talking about? We're talking about angle 3 is congruent to angle 5, or angle 4 is congruent to angle 6, okay? So angle 3 and angle 5, or we have angle 4 and angle 6. Well, if interior is on the inside, then exterior is on the outside, your outside angles, right? And it says alternate exterior angles, and it turns out, hey, guess what? Angle 2 is congruent to angle 8. So we have angle 2 and angle 8. And then what else do we have? We have angle 1 and angle 7. Angle 1 is congruent to angle 7. Same side exterior angles. Okay? Well, if you're on the same side exterior angles, they're supplementary. So angle 2 is supplementary to angle 7. Angle 1 is supplementary to... Sorry, I had to pause it and accidentally erased everything. But anyway, what I was saying is, and I thought it said exterior, it's interior angles. But same deal. Angle 3 and angle 6 are supplementary. So angle 3 and angle 6 equal 180 degrees, right? If we add those together. In the same way, angle 4 plus angle 5 equals 180 degrees. Boom. Let's do this. All right. So that was your homework. And let's go ahead, and because I had to delete everything, I'm so sorry about that. That is a quick look so you can look at it and kind of write down the different angles. Let's move on with this bad boy. We're going to talk about medians and altitudes of triangles. And I'm actually kind of excited because it's been a while since I've learned some of this. It's pretty cool. So let's watch this awesome video of the surfer right here. Surfing fascinates me. So there's two forces at work on this surfboard, right? There's the force of gravity, which is pulling down, and then there's the force of buoyancy, which is pushing up from the water on that board. And the job of the surfer is to find his center of gravity, right? That place on the board where he's got his gravity centered so that he's able to balance both forces together and stay upright on the surfboard. It's kind of cool. So that's what's happening here. And we're going to talk about that center of gravity. And in fact, today we've got some vocab going on. So I want you to take a minute and write down these 4 vocabs. We have the median, which is a line segment with endpoints that are a vertex of the triangle and a midpoint of the opposite side. So let me kind of draw that for you. That's going to look like this. Imagine that this point right here is the midpoint. The median line would be a line, imagine I drew it straight, that connects the vertex to the midpoint. Okay? That's called a median. And we have a centroid. Well, if I were to draw these three medians, which we're going to get into this in the next few pages, but this is the simplified version. If I draw all three median lines, they're going to meet at one center point. That point of concurrency, right? That's where those lines are concurrent, is going to be called the centroid. All right? And the altitude of a triangle. What is the altitude of the triangle? The altitude of the triangle is a line drawn from the vertex, so a segment from the vertex of the triangle to a line containing the opposite side. So I can draw one of three altitudes. Now, it's going to look similar to this median, but it's not, because when I draw this line down, it has to meet that opposite side at a perpendicular angle, okay? And that is the altitude. Then the orthocenter is the point of concurrency of the altitudes. So if I were to draw another triangle, right? So the centroid is that point of concurrency of the midpoints, but if I were to draw instead three altitudes, that point of concurrency right here is called the orthocenter. All right, so there's lots of different centers. We've had centers for angular bisectors. We've had centers for line bisectors. We have had centers now for medians and a center now for altitudes. So lots of different centers going on in these triangles. Okay? All right, go ahead and write down these different definitions. Pause if you need to. We are moving on. All right, now we're going to talk about the centroid of a triangle. Good times. So remember that centroid is that spot where we have that center of gravity established so we can balance an object. And what we're going to do is we're going to look at triangle ABC right here. And the first thing I want to do is I want to establish the midpoint. So this tool just helps me establish the midpoint. If you're ever like doing this on paper, you know what you can do? You can like copy the shape on paper, just fold things in half, you know what I mean? And then get your midpoint that way. That's one way to do it. You can measure it and divide the measurement by 2 and do that. There's even a way to do it with a compass and a straight edge, but we don't do a lot of that in class right now, even though I do find that fun, and if you ever want to know, ask me. But here we go. So we're going to use all the get all the midpoints, and then I'm going to label them. So I'm going to label the midpoint of BC, D, the midpoint of ACE, and the midpoint of AB, F. Awesome. Now we're going to start doing some line segments, right? I'm going to do a line segment from each midpoint to the vertex opposite of it, okay? Or from the vertex to the midpoint of the side opposite of the vertex. So in other words, from A to D. And once again, we have another area or a point of concurrency, right? We're going to call that point P of the medians. All right, so this is all the medians. A median line, remember, is drawn from a vertex to the midpoint of the side opposite it. And these are not meeting at 90-degree angles, but there is something interesting happening here. So I'm gonna do some measurements, and just go with me on this. Let's do AD first. And then I'm going to do the measurement of BD, or BE, excuse me. And then CF. You may be looking at this, I bet some of you are expecting this to be congruent, but it's not. It's not even close. If I messed up, I don't know, let's find out. I'm going to do 3 more measurements, okay? 3 more measurements. Let's do the measurement from the vertex to the centroid P. And I actually meant to do AP first, but that's okay. We'll figure that out. So I'm going to do AP, BP, and then I want to do CP. C3P. Awesome. Again, these are not congruent. Here's what we are going to do. I want to take AP, which is 8.47. Move up. So I'm going to take 8.47 as a terrible 8. Oh my goodness, what is wrong with me? 8.47, and I want to divide it by AD, which is 12.70. And let's do that. Hold on. I'm going to get 8.47 divided by 12.7. 12.7. And I get 0.67 when I round it. So roughly, so that was a division, 0.67, which is 2/3. Now, I want to take BP, 7.36, and divide it by 11.04. .36 divided by 11.04. Guess what that equals? Approximately 0.67, or more exactly, 2/3. Can anybody guess what the last ratio is going to be? Yeah, if I take 5.87 and I divide it by 8.8, I get 0.67, which is 2/3. So what we find is the ratio of the distance from the vertex to the centroid divided by the median is 2/3 every time. That's something we can use. And that's going to lead us to our next theorem. Go ahead and write this down, pause if you need to. But our next theorem is this. Dun, dun, dun. 6.7, the centroid theorem. And the centroid theorem says this: the median of a triangle intersects at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So if P is the centroid of triangle ABC, then AP, so AP is equal to 2/3 of AK. And BP is equal to 2/3 of BL, and CP is equal to 2/3 of CJ every time. That is an awesome theorem. Take a minute, make sure you write down the centroid theorem in your notes. That's what we're going to be using a lot of today. All right, pause it if you need to. Let's roll. So let's use an example of using the centroid theorem. Awesome. This one's going to be set up a little like a proof, and you'll be noticing you get some of these in your homework, so just keep that in mind. Use the centroid. If triangle ABC, in triangle ABC, P is the centroid, and BL equals 6. So what do we know? We know that this distance, BL equals 6. And because of that, I know that 2/3 of 6, or what's 2/3 of 6? Well, 3 goes in 3 once, goes into 6 twice. It's going to be 2 times 2, or 4. So we know that BP equals 2/3 BL, right? So if I want to find BP and PL, I know that PL is 2/3. That's the centroid theorem. So multiply that out, and we can do this because BL equals 6. We just put in 6 for BL. Now, I know that BP plus PL equals 6. All right? Segment addition postulate. So just know that all the segment addition postulate says that if I add segments together, they equal the whole. Okay? Well, what does BP equal? We know BP is 4. So 4 plus PL equals 6, and we can say that because BP equals 4. And if that's true, well, let's subtract that over, and we get that PL equals 2. Boom! Check that out. Awesome stuff. All right, I'm going to erase this. We're going to move on, but let's roll. All right, we're going to use the centroid theorem again. So NC equals 36. So let's see what that means for us. NC equals 36. We're basically doing the same thing. So here's what I want to do. I'm going to use the centroid theorem to find NP and then subtract that from the total of NC to get PC, right? So first things first, if NC equals 36, then I know that NP equals 2/3 times 36, right? And 3 goes into 3 once, goes into 36 12 times. 2 times 12 equals 24. So now I know that NP equals 24. So if NP equals 24, then I know that 24 plus the length of PC should equal 36 because segments make up a whole, right? Subtract 24 from both sides, and we know that PC equals 12. So what do we have here? We have NP is 24, and PC equals 12. Boom. Love that centroid theorem. Go ahead and mark this down. Pause if you need to. Lots of triangle properties. It's really kind of amazing if you think about it, how many different properties triangles have. Now we're going to apply the centroid theorem. And I want you to see problems like this just so we kind of, they're just little mini proofs almost. Because LX is congruent to XM. So we know that's the midpoint, right? LM and NX, that means and NX is the median of LMN, triangle LMN. Likewise, Y and Z are midpoints. So we know that Y and Z are midpoints. Basically, it's just setting up to say these are all midpoints, all right, of MN respectively. So LY and MZ are also medians of triangle LMN. Therefore, point P is the centroid. Great, we have the centroid. So what we want to do is we want to find LP. Ultimately, what's this asking us to do? It's asking us to find the distance LP, which is not going to be that bad. And we do know that PY, the entirety of this, is equal to 7. Okay, this is just what we've been doing, nothing different, so this is what we're looking for. Let's go ahead and look. First of all, it says LP equals 2/3 of LY. So we know that, okay? And we can say that because of, or 2/3 of LY. And we're going to change LY into LP plus PY. So we're just saying this entirety of LY is really the addition of LP plus PY. And how do we know that? That's segment addition, because when we add the segments together, it equals the whole. And substitution. We're just substituting this fact in, that if I add in these two segments, they're equal to the whole line. All right. And then let's plug in what we know. We know that PY equals 7. Let's see, I only have this little segment right here, right? PY. So I know that PY equals 7. So I'm going to have LP equals 2/3 times LP plus PY. All right, let's multiply that 2/3 out. And what do we get? LP equals 2/3 LP plus 14/3. We just used the distributive. And I did forget to do this one up here. PY is 7. That's the only thing I forgot to write right there. So we know that PY is equal to 7 because we're told that up here. And that's why we're able to substitute in the fact that it's 7. We use the distributive property to multiply out 3. Now we're just going to take this and I'm going to subtract 2/3 LP from both sides. So we have 1/3 LP equals 14 over 3, and that's from subtracting from both sides. And we're going to multiply 3 through. When I multiply each side by 3, I bust those fractions, get rid of them, and we're left with LP equals 14. Boom. Let's see if we did it. Yeah. Awesome. We're almost done for today. Our last application of the centroid theorem. Again, we're going to have triangle JKL and PT equals 2. If PT equals 2, so just this little section right here equals 2. Right there, we know that is 2. Okay? So I want to find KP. I want to find this smaller section right here, but here's what I do know. I do know that KT, the larger of the sections, is equal to, or I'm sorry, I know that KP, not KT, but KP, I know that KP, let me get a different color here. So green KP, so maybe I'll just do this in green. Is equal to what? Well, it's equal to 2/3 times KT, correct? But don't forget, KT is made up of 2 little line segments. So now I can say, all right, KP is equal to, trying to color code this to help us out, 2/3 times, what do we know KT is equal to? It's equal to the addition of KP plus PT. Okay? And wasn't I told that PT equals 2? So now I can say, all right, KP is equal to 2/3 times, it feels weird writing KP again, right? Plus, and instead of KP, what am I going to write? Or PT, I'm going to write 2. Now we're going to multiply this out. And when I distribute this out, I get that KP, may run out of room, equals 2/3 KP plus, what's 2/3 times 2? It's going to be 4/3. And I'm going to subtract this over. When I subtract this over, remember guys, I know part of your brain is going to be thinking, oh, or that's 2/3, so I got 1 whole minus 2/3. And so what's that going to be? That's going to leave me with 1/3 times KP. And 1/3 KP is equal to 4/3. Now when I multiply that out by 3, so I'm going to multiply everything by 3. And those are going to cross out, right? Because I multiply both sides by 3, and I get that KP equals 4. Boom. So our KP, go ahead and pause this, write it down, because I'm going to put it in here just so you know I'm right, not thinking I'm like messing with this. But KP equals 4. Are you ready? Ring. And that's what we're doing for today. So, peace out.